Okay, so the last thing we have to talk about in today's lecture is stoichiometry. Stoichiometry is a very imposing term that has to do with mass relationships and your balanced chemical equations. So, in other words, in stoichiometry, you can go from the mass of one of your reactants or products to the mass of a different reactant or product. Well, why is this useful? What's the purpose of this? Stoichiometry is useful in that if you know how much of one substance you want to produce, you can calculate how much of your reactant you need to have. Or on the other hand, if you know how much reactant you have, you can know exactly how much product you'll be able to produce with that reactant. So here is basically what we call the plan or the path for solving these problems. So in order to go from mass of one thing to mass of another thing, you have to use your balanced chemical equation. That's why it's called stoichiometry. Okay, so to get from mass of A to the number of moles of A, here you're going to use your molecular weight of compound A. And now A, I'm just saying that that's just any compound. And then to go from moles of B to mass of B, here again you will calculate your molecular weight of compound B this time. Both things we already know how to do. This is the part where everyone gets confused. In this section, in order to go from moles of A to moles of B, you're going to have to use your stoichiometric ratio. What in the blink is that? The stoichiometric ratio is the relationship between your stoichiometric coefficients. So, if this is my generic chemical equation, I have a ratio of 1 mole of A to 2 moles of B to 1 mole of AB2. So you're going to always get your stoichiometric ratio. It has to be from your balanced equation. That's why it's important to know how to balance equations. And it's the thing that allows you to compare apples to apples. In other words, if you don't take into account the fact that you need 2 B's for every 1 A, you're going to, you need twice as much B, basically, in terms of moles, to make your compound AB2. Which makes sense because in your compound you need 2 moles of B to get the right composition. Okay. This is the part of the whole stoichiometry process that most students have a problem with. They tend to forget this third step. So watch out for that. Okay, so in this screen, we talked about the plan or the path for solving these problems. Each one of these black letterings indicates one of the brackets that'll be in your path. Let's show how we can do this in terms of actual numbers for solving your chemical equations. Okay, so here you're going to start with some number of grams of A, and that's going to be divided by 1. That's just that place filler in your first bracket. In the second bracket, you're going to need to cancel out grams of A, so that's going to be your molecular weight number that you're calculating from your periodic table, and that's per 1 mole of A. Now this is the step where you're going to calculate from moles of A to moles of B. So here you're going to have moles of B divided by moles of A. We're setting it up that way so that we can cancel out moles of A. And then in our last step, we're going to have the molecular weight in grams of B divided by 1 mole of B. Because remember that molecular weight is just in grams per 1 mole. Okay, now let's just talk a little bit more about this bracket here. If this is my equation, I only have one reactant and one product, and these are phony things. This is the compound formula, and these little letters are the stoichiometric coefficient. Those numbers are the numbers that are going to go in your third bracket. Therefore, it's crucial that you have a correctly balanced chemical equation, otherwise you'll get the totally wrong answer. Okay, make a note of this slide here on your notes, or if you are taking notes on a piece of paper, write this on a separate piece of paper. Please have this screen handy for when we're doing our next set of examples. Okay. For now, I'm just going to do a few examples that are not in your notes or in your book or on your homework. And then we'll talk about, we'll do a few examples from that homework. Okay. Iron 3 oxide plus aluminum yields aluminum oxide plus iron. Balance this equation. Okay, so the question is going to ask something like this. If I have 135 grams of aluminum, how much iron in grams can I produce? So this is what your question is going to sound like. Okay, so this is basically a unit conversion problem. So we're going to start at the very beginning with what we know. This number right here. Okay, so let's start way over here with 135 grams of aluminum. Oh, this is an easy problem. Calculate the molecular weight of aluminum. Looking on my handy dandy periodic table, I come up with 26.98 grams of aluminum per 1 mole. Now if you caught it, good for you. I did this on purpose. What's wrong with this next bracket? The grams is supposed to be on the bottom. So let's take a look at that and fix it. This is a really big temptation for a lot of students. That's why I showed you this here. This error will not appear on the notes when you print them off in PDF. So you've seen it here, just to be aware of what not to do. And that's per 1 mole of aluminum. Okay, what's our next step? Next step is that tricky bracket. That's where we use our stoichiometric coefficients. So moles of aluminum are going to go on the bottom, and then moles of whatever is your other species that you're looking for. This is where things get a little bit tricky. All you have to do at the beginning of your problem is identify what species A and what species B. This is clearly species A because it's the stuff we have information about. This is species B. I'm merely referring to what these things are here in real life now with this new problem. A here is going to be the aluminum, and B on that next problem is going to be the iron. Okay, so then we need moles of iron. What are the numbers that are associated with these two species? 2 and 2. Okay, so you're thinking, Michelle, well, 2 divided by 2 is 1. Why do we have to go through all this work if it's not going to yield any mathematical difference in our answer? The reason is because if you don't, you won't have converted these units. Just because it yields 1 right now doesn't mean that it's ever going to do that again. So that's why it's a good habit to get into. Even if all of these numbers were 1, we would still not be able to skip this step. We're not talking about things in terms of each individual problem. We want to be able to learn the process so that we can apply it to all problems. Okay, so in this next bracket we need to cancel out moles of iron. And here is again where we have to calculate that molecular weight. And for iron it's 55, I think 0.45. Oh, excuse me, 0.85. Grams of iron. Okay, let's take a look here real quick and make sure all of our units are canceling. Oh, and that's per 1 mole. Moles iron, moles aluminum, grams aluminum. Therefore, our final unit is going to be grams of iron. Is that what we're looking for? Yes. How much iron in grams? That's our question mark. Okay, so now all you have to do is do the math. You should take 135 times 2 times 55.85. And if you don't have brackets on your calculator, that's okay. Hit enter. Divided by 26.98, enter. Divided by 2. If you don't hit the enter in between those two steps, you'll think that, your calculator will think that you're supposed to divide this by 2, and that's wrong. So after you do the math, as long as you get this as an answer, 278.1 grams of iron, or something close to that, you're correct. How many significant figures should you have? If you answered that this is right, you're wrong. You need to have 3 because you have 3 here in your problem. Okay, let's do more examples. This is our next chemical formula, or excuse me, chemical equation. Iodine plus Na2S2O3 yields NaI plus Na2S4O6. That's a 6. Okay, balance this equation. Don't forget that you have 2 places on this equation where you have sodium. You have to add them together. Okay, so here is your question. How much NaI is formed if 323 grams iodine is reacted? Okay, what I want you to do is take a look at your plan and the example that we just did. And I want you to try to solve this by yourself. So pause the movie and come back. Okay, we start out with what we know. And in the next bracket, we have to cancel the grams. So here's where we need to calculate the molecular weight of I2. That's iodine on the periodic table times 2. So you should get 253.81, and that's per 1 mole. Here's your tricky step. You have to cancel out moles of I2. What's the substance that you put on the top? You need moles of something. What's it going to be moles of? It's not I2. It's not this thing. It's not that thing. It's the other thing that's asked about in your question. NaI. Okay, now I would suggest that you put your units here first and then fill the numbers in. Okay, so I2 has a coefficient of 1. And NaI has a coefficient of 2. Okay? Now let's do that last bracket. Here we have to cancel out moles of NaI. And that's always per 1 mole because we have to calculate molecular weight here. And that answer is 149.85 grams of NaI. Now I want you to do the math and see if you come up with this as a final answer. 382 grams NaI. Is this the right number of sig figs? How many sig figs did you start with? So that's right. So I can make this 382 grams of sodium iodide if I start out with 323 grams of iodine per this reaction. Okay. Now I want to do one from the book homework together. So this will be page 156, number, we'll do 42. Okay. So it says, magnesium reacts with sulfuric acid according to the following equation. And then it gives this as your equation. Mg plus H2SO4 yields MgSO4 plus H2. Okay, you should always write the equation down on your paper, and then you should always make sure it's balanced. Some of these ones in the book are balanced, and some of them aren't. Is this balanced? Yes. That's easy. Okay, so then moving on. How many moles of H2 are produced by the complete reaction of 230 milligrams of Mg with sulfuric acid? Start with what you know. I'm so glad I picked this one. What do you notice about your unit there? It's milligrams. We can't go from milligrams to moles in one step. We have to convert that back to grams. So let's take a little bit and do that. that. Hope I don't run out of space. We have to put milligrams on the bottom. There are 1,000 milligrams in 1 gram. Now, you can calculate your molecular weight of magnesium, which is 24.31. For 1 mole. Stoichiometric coefficient time. Start by doing this, because you know you have to get rid of that. And then what goes on the top? Okay, I've got to go back to read my problem because I forgot. How many moles of H2 are produced? Ah, that means that this goes on the top here. Now fill in those numbers. And now I did run out of space here, but you should keep this all on one line, otherwise it gets messy and out of control. Then we are going to calculate the formula weight here of hydrogen, and that would be 2.02 grams of H2 per 1 mole. And you should get for an answer a number you have to put into scientific notation. 1.9 times 10 to the minus 2 grams of H2. Now, does it specify, oh, this is excellent. I'm so glad I made this mistake. Look back in the book for me. What are you trying to find? Are you looking for grams of H2? You're looking for moles of H2. Okay. So here I calculated an answer, but what would happen to you if you did this, like I just did? Well, I take off a whole point because you didn't answer the question I was asking. Okay, so, teachable moment. This is what you do. This is what you're supposed to do. 230 milligrams of MG. You still have to convert to grams. You still have to use the molar mass, or the molecular weight. I forgot what it was. 24.31. You still have to do the stoichiometric coefficient. But now look what your unit is. You have moles of H2. So here is where you stop. The point of this problem is that you're not going all the way through all 4 brackets of your original path. You're stopping at bracket 3. So therefore, your answer then is going to be 230 divided by 1,000 divided by 24.31 equals 0.0095 moles of H2. I expect this number to be in scientific notation, so make sure that you do that. Okay, so the point of this problem and the teachable moment of my error is make sure that you are solving for what you're looking for and that your final unit coincides with what your book's looking for. Sometimes it helps to write down that question, well, you know, what you're looking for before you start solving the problem, so you don't get into a situation like this where you have to resolve it. Okay, so that's number 42 on your homework, and from the book. Now here is a question number 1 from the typed out part of your homework. Okay, so let's just do this one together. Balance the following chemical equation. I don't even have my answer key here, so here's where I'll show you how horrible I am at balancing equations. I am bad at it. 10, 11. I have what's called very bad spatial intelligence, so it's hard for me to see what to do. Alrighty, so it looks like we're going to have to start out by putting a 4 here. Then this will be a 4, this will be a 12, and this will be a 16. Oh, Glory, what do you do now? Alright, well let's try to change that hydrogen next. Let's try plopping a 6 there. So this would be a 12, you'd have 16 oxygens. Oh, that's balanced. Oh, that's nice. Okay, so how many moles of H3PO4 are produced if 1.34 grams of H2O is reacted? Moles only. You don't have to go through that last bracket to get to grams. Okay, so let's start here. 1.34 grams of H2O. Then we have to calculate the molar mass. 18.01 grams of H2O per 1 mole H2O. Oh, golly. I have no idea why it does that. Alright, so then the third bracket is your stoichiometric coefficient. Write mole H2O on the bottom. On the top, write mole whatever thing you're looking for. H3PO4. That's phosphoric acid. Put your numbers in. Now all you have to do is solve the problem. You should be able to get the right number. Okay. Now, this question asks how many grams of H3PO4 are produced. Okay, there are 2 ways to solve this problem. One is really long and one is really short. You could start at the very beginning of the problem here and work through the whole path and add the last bracket to convert moles of H3PO4 to grams. Or you could take whatever answer you get here, multiply it by the molar mass, and you've got your answer. In other words, this gives you a number x. X moles times your molecular weight, grams per mole, gets you your answer, y grams of H3PO4. And that's all there is to the stoichiometry. If you follow the 4 bracket path steps, you will not go wrong. If you have any questions, please email me. Please do post questions in the homework number 3 forum. And if you can get to me that extra credit question by Friday at noon to my Gmail, don't send it to my Jewel because I don't get your emails when you send it there. I will give you 5 extra credit points on homework 3. Good luck.